Here we go again. Again, I'm just so bad at recording these, apparently. I, this isn't, again, try number two or three or whatever it is here. Anyway, I'm going to try and keep this short and sweet, just so we can all just keep moving on kind of with our life here. So, hi, what is that preamble? Who am I? Why am I even rambling to you? My name is Alexander Booth. I am the instructor and facilitator for the IBM data science class. I did my whole introduction last week in my recording. But know that I'm going to be doing these recordings each week through the rest of the class, just so you get a quick idea of the big ideas I want you to take away from the last week, as well as what to focus on in the current week. So we are wrapping up module two, and we should be focusing on module three, at least for the next few days. I think we actually end on Wednesday for module three. So a couple days late on this recording, but I'll make sure to try and do better on that in the future. My goal is to hopefully have these recordings posted on Fridays, as opposed to, I think, Sundays, which I've been doing for the first couple of weeks. So just, yeah, bear with me. Life gets in the way, as you all know, since we're all taking this async anyway. Cool. So where are we? Who are we? What are we doing? Where are we going? With week one, module one, your big idea was to start thinking like a data scientist. What I mean by that is starting to frame questions in a data-driven way, right? We talked about the crisp DM paradigm, as well as some other ways of just breaking down questions and trying to make them data-driven. For example, what is the business use case? Why are we having to ask this question? Then what data do I need to answer this question? What are my hypotheses on what this data will say? How can I clean up the data? How can I communicate the data? How can I create data products and data models off of this? And then how do I actually take my results and make a difference, right? What is my actionable insight that I can make from this data? So a lot of ideas like the scientific method, hypothesis testing, and being data driven is kind of what I wanted you to take away last week. This week, the focus has shifted to computer science. So I want you to start thinking like a computer programmer. Again, not really getting too hands-on. We'll build into that over the next, I think, about 8 more weeks here. So we'll continue building on that. But I want you to start just having the mindset of why automation, why write code, why create programs, and what does a program even look like, right? Especially like a modern kind of coding, data science oriented program. So we'll just provide an example, right? Last week we talked about how data products are no longer just single reports, right? Or like a one and done, I think is what I called them last week. So the idea there is a white paper or a slide deck. You read it out and share it around once and then call it a day, right? That's kind of no longer what a data product is. Instead, after we do our data analytics, we create a machine learning model that needs to be retrained every week on new live data. We create a dashboard that needs to be updated every single day with new revenue and new kind of cost of goods sold and all that good stuff. Maybe we create a AI chatbot, a RAG application that has new documents provided to it every week, right? We need to make sure that all of those are processed correctly. It's no fun to have to wake up at 2 in the morning and do that manually. Let me tell you, I have had to do some of that from experience. So again, like let's say that you have to update your model once a week on a Sunday night, right? But the data doesn't arrive till 1, 2 in the morning. At that time, you would have to log in, kick off the job, and make sure that your model is actually succeeding in its training, and then go back to bed and hopefully wake up the next morning to a brand new model. And hopefully everything just has worked. Fingers crossed, knock on wood. That's a pain. It's a pain to manually update dashboards every day. It's a pain to manually go get new CSVs every day and shove them into your Excel spreadsheet, right? Um, there's actually a really cool book that I'll probably share as well. That's called like How to Automate the Boring Stuff, kind of with Python. And that's really where I see computer programming, especially in its application with data science, is we don't really need to spend all of these manual hours acquiring data, cleaning data, especially when it's repetitive, right? If we're getting new data each day, but it's from the same vendor. It's probably got the same data cleaning steps. It's got the same data acquisition steps. It's got the same data modeling steps. So why do the same thing every single day, right? Instead, we can write a computer program to go out every day, get this data from web scraping or APIs or what have you, clean it up, organize it, and then append it, add it to the end of a table in a database, right? And then call it a day. And maybe we just get an alert if the job fails. So I can peacefully sleep through the night unless my job has failed, my program has failed, in which case I still get the pager alert or pager duty, Slack, Teams, kind of whatever alerts you like. So that's kind of the idea of why, right? Um, TLDR in summary, modern data products are evolving, right? They are ever evolving. They adapt every day, every week, every month to new data, whether it's a machine learning model, a dashboard, an AI application, whatever. No longer do we create static data products. We create of ever evolving dynamic data products. So to facilitate that speed to insights, we need to make sure that we use computer programming to help automate the boring stuff, right? To overnight go get the data, retrain the models, update the dashboards, and maybe not even overnight, maybe every hour or sometimes every couple of minutes or every few seconds, right? So that's kind of the big idea of the why. So the what is computer programming, right? How do we actually do this? Well, in my live session, I covered the four pillars of computer programming, and note that all of this transcends Python. It goes into hand in hand with any programming language you may use over the next few weeks, months, years of your career. So again, personally, this is things like Python, Rust, Go, Julia, C++, C Sharp, COBOL, Visual Basic for my OGs out there. Any of these languages will kind of be focused on these four big pillars of computer programming. So, what are they? First one is variables and data structures. These are going to be your nouns or your building blocks of any program. Think of x equals 5. X is the variable, 5 is the value. X isn't a very human readable or understandable name. So typically you'll see these variables with context, right? So maybe it's going to be something like number of months equals 6. Now I have context. This variable name means that this value represents the number of months that something needs to happen in my program. Data structures are going to be ways of organizing multiple items or multiple objects into one structure. The most common structure is a list, just like a to-do list or grocery list. Milk, cheese, strawberries, beef, chicken, celery, broccoli, blueberries, melon. Maybe I'm listing my own grocery list right now. Never mind. But anyway, that's the idea, right? We have these single text, these single strings that we can then organize together into one structure known as a list. This can also be a list of numbers, 6, 7, 8, 9, 10. This could be a list of dates, a list of decimals, kind of what have you. Besides lists, there are a few other data structures you should know that are covered in the media sets. Dictionaries, which are going to have key value pairs instead of indexes inside of a list. Tuples, which are going to be unchanging or immutable lists, and sets, which are going to be unique lists, a list that only contain a single item once. Cool. So, and these are going to be our nouns. These are going to be either driving the action or what the action is happening onto, right? And as we get into pandas, you'll start hearing things about data frames. Data frames are just a more advanced data structure, ways of organizing data into representative rows and columns to make it familiar, like CSV or Excel spreadsheets, for example. The second pillar you should know is conditionals. Conditionals are if-else statements, and they control the decision making, control the actions that are happening inside the program. For example, let's say if you are over the age of 17 in the United States, then you can go to this R-rated movie. Else, you have to go to a PG-13 or PG movie, right? So if one thing is true, then do A, else do option B. Where conditionals get fun is where we add in additional checks. So we add some and or clauses. If I am under the age of 17, or Or maybe it's if I'm over the age of 17 or I have parent and guardian consent, then I can go see this movie, right? Else I have to go see what other movie. So even if I am under 17, if my parent or guardian is there, then yes, I can go see this movie, right? So that also is known as an else if, right? You can maybe be able to kind of feed that in as well. If I'm over the age of 17, I can see this movie. Else, if I have a parent and guardian, then I can also see the movie. Else, I'm stuck going to see Minions 5 or whatever kind of the newest kid movie is out there. I should know that because I do have a kiddo. So I don't even know what he's watching these days. Random Sonic the Hedgehog stuff. All right, getting too personal. Let's bring it back. Besides variables, data structures, and conditionals, we also want to discuss loops. Loops are the iteration and repetition handling for our coding blocks. Two types of loops you should know. While loops will iterate until a condition is met, and for loops will iterate a set number of times. So big idea here is, let's say you have a user and they're shopping on your site. While the user has yet to click pay now, then we'll still let them add things to their site, right? Or while the user has yet to type in stop, we're going to keep iterating through our code block. A for loop will be something like, I want you to ask this person 10 times if they want to buy candy, right? So we have 10 iterations that we need to do and exactly 10. So we'll use a for loop for that. And the last kind of pillar of computer programming you need to know is functions and classes. At a very, very 10,000 foot view, functions and classes help us organize and reuse code. And that is all you need to know about functions and classes in Module 2. There's a lot of intense stuff about functions and classes, but it is not required to know much about object-oriented programming, creating your own functions or any kind of that jazz. We'll build on that as the program goes on. But big idea here is let's say that your CFO has defined revenue for your company as, let's say, rolling last 30 days. So maybe in all your different programming, you have this logic of revenue is the last rolling 30 days for XYZ, whatever, right? And then the new CFO comes in and says, hey, actually, it's 90 days. It's pretty inefficient to go into all of your many programs where this revenue metric is utilized and change the 30 to a 90. So instead, we can define revenue at a global level as a single function or a single metric. And then once that's changed to 90, we change it once, and all of our sub functions or subclasses then reference that singular function. And hopefully, we don't have to go into the weeds of everything and do it. So, idea is reusability, right? Define the logic once, use that logic in multiple places. So that's the big idea behind functions and classes as well. So to reiterate, your four big pillars of computer programming for any program you'll ever write in any code or any language are going to be variables and data structures, conditionals, loops, and functions and classes. Again, this is going to be mostly M2.1 to M2.7. Those are going to be where I would recommend you spend the most time in Module 2. Finally, the last half of Module 2, we dove into some Python and data science specific use cases. Again, mostly going back to that original idea of writing a program to automate the boring stuff. Every night, go out, get new data, clean it up, and then do something with it, right? And we're going to be using Python for that. So we introduced two ways of acquiring data, web scraping as well as APIs. We're going to go a lot deeper into that in week 3. So all you need to know right now is whenever you are acquiring data from a vendor, from a source, always consider ethics and terms of use. This is why there are many different vendors called data vendors or data providers. You sign agreements and contracts to buy different organizations' data, and then they make it available to you via APIs. Whenever we're acting as hobbyists and acquiring free data from across the internet, note that sometimes it's not always free. During the live session, I showed an example where I showed a website that I've scraped in the past, maybe off the record, And now in the terms and conditions, it says that it does not allow the unauthorized use of bots and scrapers that are just automated going out and acquiring data on the site without authorization. So again, just think about that ethics as you go into module 3. When is it okay to get data? What does it mean by that, etc. So the other example I like to call out with this is like your public Instagram, your public Twitter accounts, your public Facebooks. All of that information is accessible via Facebook and Instagram's APIs. You can go Google it. You can go look for it right now. Instagram API, and you'll find it. And if you have a public Instagram, anyone can go pull and scrape your data without any consent from you because you already signed that consent form when you signed up for the account. So again, maybe that's why most of my stuff is most of my stuff is completely private. But at least that's my own thing too. So again, just the big ideas to think about going into week 3 is the acquisition of data, and especially if you're not paying for that data, kind of what's ethical and kind of what do you think about all these organizations trying to lock data behind terms of use, or kind of restrict it. So another kind of real story on this. Also, maybe I should share my screen. No, I'm not going to bother. This is supposed to be quick recaps. You can Google it though. So basically, Twitter kind of locked down its free API, and now you only get access to a very, very small subset of data from Twitter through its API, at least for free, and they want you to pay for it. And that was a whole ruckus of things. There's also been other examples of big tech organizations buying smaller free like APIs and shutting them down. An example of this is Apple, who bought Dark Sky, which was a competitor in terms of weather, like weather apps and stuff, and they just shut it down. They just shut down the Dark Sky API, and I was like, I had programs and API keys there, and I'm like, well, what do we do? What? Anyway, maybe I will share my screen because I think this is really interesting. Yeah, you can see I am trying to quote from my live session notes here, which are all in the discussion forums. So definitely make sure you're checking out the discussion forums here. But let me actually just, this was it. Twitter API free edition limits. Let's see, this is a while ago. It's like, yeah, the free edition of Twitter is like offers like less stuff, right? Oh yeah, here you go. This is April. Yeah, Twitter API term, building applications after the API restrictions. Yeah, so that was a big thing in April 2025. Yeah, end of last year, earlier this year, right? Twitter's plan to cut off free data access, and X makes its API tier more costly. There you go. Fair amount of panic among data scientists. So there you go. So anyway, this is something that I thought was really interesting. And what was the other one? I don't care about AI mode. Apple Dark Sky acquisition. There you go. Yeah, this is a couple of years ago. Yeah, basically they acquired Dark Sky and then they discontinued the API and they shut down the API. And I was like, oh, what the heck? Dark Sky is done. Yeah, Apple acquires Dark Sky and just shuts it down. Yeah, it was wild. Yeah. So they literally just killed the guy. So yeah, anyway. Uh, yeah, worst case scenario. Yeah, anyway, that's just some things I wanted to bring up around data acquisition, right? So we talked a little bit about web scraping and getting data from websites. We also talked about getting data from APIs. In the labs, we showed how to acquire data from Wikipedia. Wikipedia actually has a real API that I recommend you utilize instead, as well as then how do we get that data into a data structure that we can do analytics on, kind of with pandas. So going into week 3, that's where we're really going to be focusing on. Now that we kind of are thinking like a computer programmer, automating the boring stuff, bringing in these variables, data structures, conditionals, loops, functions, and classes, how do we start applying that to data, right? How do we start bringing data in to our notebooks, our environments, and then how do we start manipulating and interacting with that data using Python, libraries such as pandas, and visualization libraries such as Plotly and Matplotlib. So that's what we're going to do in week 3. In week 3, your 10,000-foot view is actually kind of taking these thinking like a data scientist, thinking like a computer programmer, and start putting that into reality, right? Start actually building code and programs to take data from wherever you are acquiring it and have an understanding of common ways of acquiring data, and then starting to apply programming principles to facilitate the ideas of crisp DM, for example, right? So, how do we actually create leaderboards, create data products, do data cleaning, create models, and apply that back to business value? I think after week 3, we're gonna take a short detour into SQL for for just 1 week, and then we're gonna come back into some more advanced Python activities. As you'll see, basically where we're gonna get to is that APIs and web scraping are not the only ways to acquire data. Databases are also a very common way of getting data into your notebooks. So querying data from a warehouse and then doing something with it, and also vice versa. Now that you've acquired data from your source, how do we clean it, manipulate it, then write it back to a database or a data warehouse? So that's a little bit future looking into module 4. What is a database? What is SQL? All that good stuff. Awesome. Let's see, some other logistic things. Definitely recommend utilizing Kaggle Learn for additional hands-on practice. So I shared 2 links, the Intro to Programming and Intro to Python. They're both pretty short, pretty quick, and really help accentuate the big ideas from Module 2. They're also completely free as well. For Module 3, I recommend utilizing the Pandas Kaggle Learn activity, which again I'll share probably during our live session on Monday. Let's see. All the lab links should hopefully be working. At least they are all working in Module 3. Either way, I've backed up all of the labs into my GitHub, and you can run them on Google Colab if you have issues. The discussion forums are still down, so check the week 1, and I'm just going to be adding as many topics as I can to the week 1 forums. I think it was a lower priority to fix the discussion forums when also the labs were having kind of those issues last week too. So hopefully we get resolution on the discussion forums, but it's not the end of the world. Just check back to the week 1 forum and find whatever topic is applicable to you and the week that we're at. That's also where I'm going to be putting most of my announcements and recordings, such as this. Let's see. Don't forget to do your end of module quiz at the end of each week. Reach out with questions or concerns, even with quiz questions or whatever you have on any of the topic forums. Karen and I are auditing them daily. And yeah, honestly, just have fun. Be happy just being exposed to so many new topics. And I know it's overwhelming. I've been through it. I've had done many, many boot camps and classes like this, especially in the first few weeks where it can be so overwhelming. Just take a step back, right? You're not the only one here. We all feel overwhelmed. Reach out to some of your classmates or reach out in the forums. And again, just really focus on the high level 10,000 foot view activities. I don't care if you know how to code in week 2 or even really in week 3, right? But you should kind of start to know these principles of like, what is data science? What is thinking like a data scientist? What is thinking like a programmer, right? We're going to iterate on this over the next couple of months here. So definitely by the time we get to week 10, you'll look back at week 2 and be like, oh my God, I can't believe I was freaking out about a for loop when it didn't really matter anyway, right? So yeah, just hang in there. Y'all are doing great. I'm loving the engagement in the live sessions we've had the last couple days. Try and tune in tomorrow if you can. And otherwise, look out for my updates in the discussion forums. Please react with thumbs up if you read something, just so I know that somebody saw it somewhere in the world and I'm not just shouting into the ether. And yeah, have a great weekend, have a great night, and hopefully I see you all on Monday. Take care.